Problem number 2. Find the difference between the areas of the two right triangles, ABC, that's the big one, the outer one, and BCD, that's the one inside. And we're told that BC is 18 units long, and BD is 30 units long, and AD is 9 units long. And we're supposed to find the difference in the areas between those two triangles. So there's a number of different ways you could approach this problem. You know, actually, and I think this is the way I approached it too. I automatically saw right triangle, hypotenuse, leg. Let's solve for this leg, and then we can find the area of that right triangle and the area of the other right triangle, and then subtract the two. So, so if we use the Pythagorean theorem, this is just one way to do it. Pythagorean theorem. Okay, so then we would take, well, let's see. If we take 30 squared minus 18 squared and take the square root of that, then we will get this leg right here. So this would call this x. So x is equal to that. That's just from the Pythagorean theorem, kind of rearranging it. A squared plus b squared equals c squared. C squared is 30, or c is 30, and we can say b is 18. So if we rearrange that, we can get x on this leg. And if we do that calculation, which, given that I told you on the problem set not to use a calculator, the calculation is a little tedious. We had to square, well, 30 squared is easy, 900, and 18 squared, and then take this, and then subtract the 2, and then take the square root of it. We end up getting 24. Okay, so x ends up being 24. I'm obviously taking shortcuts here because I'm going to show you an easier way to do it. And then we could take we could find the, let's see, let's find the area of the big triangle first. So essentially, if we have 24 plus 9, that's 33. So 1/2 base times height, 33. That will give us 297. And if we take 1/2 base, and this time let's take the smaller triangle. So the height of that one will be 24. And then we get 216. If we take the difference there, we get 81. Okay, and 81 is the correct answer. We get 81 square units. Units. Alright, that's the hard way to do it. It's doable. Without a calculator, it's a little tedious. It's a lot of work, but, you can do it that way. But one thing you might notice is that essentially we're looking for the area of this triangle, right? The difference between the areas of the two triangles will be this area here. So we would like to find the area of that triangle. So, but that's not a right triangle, okay? And we need a base and a height, 1/2 base times height. And the key to this one is actually now you can either turn your head or rotate your paper. I'm actually going to come down here and pull another picture up here. This is the same picture, only rotated 90 degrees, okay? Oops. And so then you can see that if you take 9 as the base and the height as 18, you see this is the area that we're trying to figure out, and it's essentially an obtuse triangle with a base of 9 and a height of 18. Okay? And then we could just take 1/2 times the base, which is 9, times 18, which will give us, half of 18 is 9, so 9 times 9 is 81. And that's a lot quicker to get the area that way, and just recognize that it's the area of a triangle, and that essentially we're given the base and the height, but you have to sort of shift your perspective in order to see that as to see this as the height and this as the base. Okay, so so always be looking for those things. You know, it's you know, in problem solving, the best tool you can have is just the ability to look at problems in different ways and change your perspective on them. So either way, you get 81 square units. So there's your answer.